Hi everyone. In this video we're going to go through 15D, properties of mean and variance. So we've already covered the mean, the variance, median, interquartile range, looking at percentiles and so forth. But in 15D we're really looking at the mean and variance of linear functions. So this looks a little bit scary, which it isn't. All right, so what we basically have here is just a linear function. So if you think of it as being in the terms y equals ax plus b, where a is your gradient and b is your y-intercept. So it's just a linear function. The reason why it's different is because for any other function, this rule doesn't apply. So if we're calculating the expected value, we can't just use this relationship. Okay, it doesn't exist except for if it is linear. So if your function g is linear, the mean of a linear function x is equal to the linear function of the mean of y. So that's what we're going to be looking at in 15D. All right, so just in these two green boxes following, so for any continuous random variable x, so if we're looking for the expected value of this function, ax plus b, so a linear function, you can just equate it to be this. So a being the coefficient of x times your expected value plus b. Okay, so you don't have to go through a lot of working out, you can just apply that rule. And the same with the variance. So if you've got a variance of a linear function, you can just do a squared times your variance. Okay, so it's a little bit different if you've got a non-linear function, and that's kind of what we covered in the previous sections. All right, so the probability density function of ax plus b, so a linear function. So this basically just talks about the transformations that are happening. So if we've got a, that's a transformation, and b is a transformation, okay, of the equation y equals x. All right, so a is a dilation factor and b is a translation. So if the probability density function x has the rule f of x, then the probability density function of x plus b, okay, so we're still, value of a is just 1, so we haven't had any dilation, we've just had a translation. So the translation, it means it's moved to the right, just getting my, by b. Okay, so it's the same as the rule fx minus b. So you kind of need to go back to your knowledge of transformations for this, but it's not overly complicated. It does seem more complicated than what it needs to be. All right, so we've just done x plus b, but if we've got the dilation ax, that's just a dilation factor. Okay, so it's a dilation factor of a from the y-axis, and when we're looking at the transformation for a probability density function, it just becomes 1 on a times fx on a, just to allow for the area under the curve. Okay, so I didn't highlight that very well. Just re-highlight that. Okay, so then if we bring the two together, the two transformations, ax plus b, we get this. So your point xy now becomes ax plus b, y on a. Or your rule is 1 on a times this. Okay, so that's basically all you need to know. And did I put it in a summary? I don't think I did. So only a couple of questions for this because it's a very small part of the topic that you need to know. Let me just read this last line. In the case that a and b are positive, this is the dilation of factor a from the y-axis and factor 1 on a from the x-axis, followed by a translation of b units in the positive direction of the x-axis. Okay, so it's just talking about the transformations there. So in example 12, we're just looking at, what are we looking at? 3 different examples, or is there just, anyway, we'll go through the examples anyway. So suppose x is a continuous random variable with a mean of 10. Remember the mean, we use that symbol mu, and standard deviation, oh sorry, not standard deviation, variance, it does say it there, sigma squared equals 2, and that's really hard to see, so I'm going to get rid of the pink highlighter and maybe use my yellow highlighter. All right, so mean is 10 and your variance is 2. So mu we use to represent mean or expected value, and sigma we use to represent standard deviation, and the variance is just the squared of the standard deviation, so sigma squared. All right, so in part A, we're finding the expected value of the linear function 2x plus 1. So you can see in that linear function, the value of A is 2. So let me just get a different, I'll use green. So value of A is 2 and the value of B is 1. So if I go back to this rule here, all right, so this one here. All right, so what we're doing is just taking that value of A and multiplying it by the mean and adding B. Now the mean was given to us in the question. All right, it was 10. So it's 2 times your expected value, which is 10, which we're given in the question, plus B, which is 1. All right, so the expected value is 21. With the, so moving on to question B, the variance, 1 minus 3x. Okay, so this time your value of A, now if it's easier, you can rewrite that as negative 3x plus 1. Might help you find the value of A and B. So A is always your coefficient of x, so you can see it's there, negative 3. And the value of B is your constant. And we don't use, let me just go up to a variance formula, which is here. We don't actually use the value of B for the variance. So the B is kind of irrelevant here. Okay, so negative 3 squared is 9. 9 times 2, so that, remember the variance was given to us here, is 18. Sorry, 9 times 2 is 18. All right, question C. If x has probability density function f, describe the rule of a probability density function g for 2x plus 1. Okay, so we're just looking at the rule g of x, all right, in its generic form. Okay, so 1 on A, so these are your, including all your transformations of g of x. All right, and then it's just a straightforward substitution. So if we know that A is equal to 2 and B is equal to 1, we're just substituting A and 1 into that function. All right, and that just shows us the transformations that have occurred to g of x. Sorry, not to g of x, for g of x. All right, let's move on to some questions. So for question 2, for certain glass ornaments, the proportion of impurities per ornament is a random variable with a density function given by, so we've got this function here, 3x squared over 2 plus x between 0 and 1. So the value of each ornament in dollars is V equals 100 minus 1.5x. So that's the value of each ornament. Find EX, your expected value, and the variance of X. All right, sorry, I just had to pause. So this isn't actually, we're not finding the expected value of a linear function. So this kind of goes back to one of the previous topics where we're just finding the mean or the expected value. So let's do the expected value first. So we're going from 0 to 1. When you're doing the expected value, it's just x times f of x. So f of x being 3x squared over 2 plus x dx. And I might just expand that x in. So we've got 1, 0. So x times 3x squared is 3x cubed over 2 plus x squared. All right, so you can just do that. Oh, sorry, that should be a 0. So you can just do that by hand or on your calculator. Just because I'm a bit short on time, I'm going to do it on the calculator. Okay, so stop there. Oh, so I'm doing the non-expanded version. So this is just doing the first line before I expanded it. But, you know, you can do whatever one. Just make sure I've got everything on there. So x times 3x squared over 2 plus x, beautiful. I'm going to keep that as an exact value, so I might just change that. So 17 over 24. All right, so then your variance. So we do need to use the variance formula. So we don't apply what we've just gone through because that's for a linear function, not just for the variance. And I can't remember off the top of my head what the variance is. So yeah, there it is. So which you can't see me doing. So just here. So the variance ex squared minus. I might just write that down before I forget. Scroll. Too far. Now it wrote it as mu squared, okay, but I'm just, because I used ex before, I'm just going to use ex all squared, which is the same thing. So we've got to find the expected value of x squared. So when we do that, 0, 1, instead of x, we write x squared, so whatever your function is, times 3x squared on 2 plus x dx. And again, I'm just going to do that on the calculator, but have a go at doing it by hand. It's not a hard one to do by hand. All right, so I'm just going to scroll down to the power of 2. All right, so 11 on 20. So your variance, probably should write the notation, what we're doing. All right, so we've got 11 on 20 minus your mean squared, so 17 on 24 squared. I'm just going to do that on the calculator. All right, so 139 on 2,880, but let's just change that to decimal. No, you don't want to change to decimal for me. There we go. Let's make sure it's right. So 0.0482. All right, so part B, hence find the mean and standard deviation of V. So V is the value of the ornament, not V for variance, and we might need a little bit more space. So let's just go on to the following page. And I want you to move down. Thank you. All right, so for part B, let me just write B here. Okay, so your function is linear, so 100 minus 1.5x. So we're finding the expected value of that. So 100 minus 1.5x. So if we use the rule that we did up here, okay, so first one for mean, this one here, we've got A times your expected value plus B. So your value of A is negative 1.5. And we're timesing that by your expected value, which we've worked out to be 17 on 24. And then we just add B, which is 100. And then we can just do that on the calculator. All right, so 98.94, because it's dollars, so 98.94. All right, and then what was the other thing? So that's your expected value. So your expected value of each. So your mean value of each ornament, basically. And then what do we have to do? Standard deviation. All right, so to get your standard deviation, you do need to find your variance. So we're finding the variance 100 minus 1.5x. So if we just go back to the rule up here, so with the variance, we're just doing a squared times variance. So a being the coefficient of x, so negative 1.5, times your variance, which we worked out before. I'll just leave it as its decimal value, so 0.0482. All right, and we'll just do that on the calculator. Now with the variance though, I'm going to drag down that answer, so 1.5 squared times, and I'm just going to drag this down. Now you'll notice I did positive 1.5 because when you square a number you get the same answer, so to save myself writing using a few buttons. All right, so 0.11. So that's your, actually I probably should do a few more decimal places because we've got to find it. So 1.08. So your standard deviation, which we use sigma, is the square root of that. All right, we can just do that on the calculator. So the square root, and I'm just going to drag that down. So 0.33. And remember, we're looking at value, so it's going to be $0.33. All right, let's move on to question 3. I've got about 7 minutes before a meeting. All right, so let x be a random variable with probability density function. Okay, so we're going to find 3x and var 3x, 3 minus x and 3 minus x, 3x plus 1. All right, and the rule of a probability density function for 3x and the rule of a probability density function for 3x plus 1. Okay, so there's a bit going on here, so let's just quickly go through it all. So they're all linear, but we've got to find the expected value first. So let's find the expected value. Okay, so we're going from -1 to 1. X times f of x, which is 3x squared. So this is just the rule for the expected value. All right, we'll just quickly do that on the calculator. -1 to 1 x times 3x 2x. Oh, but 0. How did I get 0? Actually, I shouldn't doubt that. Sorry, I paused to check my answer and I'm like, of course it could be 0 because you're going from -1 to 1. So it is possible for it to be 0. Now, what is it, a cubic as well? All right, so now to get the variance is ex squared minus ex all squared. So we do need to just quickly substitute in x squared. So I'll quickly do that. -1 to 1 x squared times 3x squared on 2 dx. So I'll do that on my calculator. All right, so 0.6. I'll leave it at 0.6 because that's a terminating decimal, so that's not too bad. Okay, so your variance, oops. All right, so your variance is going to be 0.6 minus 0 squared, which is just 0.6. All right, so for the first one, which I probably shouldn't have written A there. Okay, so A3x is just going to equal 3 times your expected value, which is 3 times 0, which is 0. And then your variance is equal to 3 squared. So I'm just using the rules from before. 3 times your variance. So 9 times 0.6, which I would be able to do if I had it as a fraction, but I'm under the pump. Actually, I think it's 5.4. It's funny, sometimes I do it quickly in my head before I even do it on the calculator. All right, so basically once we found the expected value and the variance, we can then just quickly apply it to all of these. All right, so let's quickly do B. So this won't take us long now because we did the hard work before with finding the expected value and the variance. And these are all linear functions. So e of 3 minus x. So your value of a is -1. So we're going to have -1 times e of x plus 3. So that's just going to be -1. Your expected value was 0 plus 3. So it's just going to equal 3. Your variance so your coefficient of x is -1, so it's -1 squared times your variance, which is 0.6. So 1 times 0.6 is 0.6. So if you're wondering where I'm getting these values from, just to recap, we did it before. The expected value is 0. Your variance is 0.6. So I just use them over and over again because these are all linear functions. Okay, so that's what this topic is about. All right, let's quickly do C. All right, so E3x plus 1. Actually, I'm going to skip C because I am going to be late for a meeting. Let's do D. So the rule for the probability density function for 3x. So 3x, so A is equal to 3. So with your rule, let's just do the general rule of g of x. Scrolling back up here. Okay, so I'm just looking at this one here. All right, so 1 over a times f of x minus a. I'm not going to remember that. 1 over a times f of x over a over memory. Oh no. 1 over 3 times f of x over 3. Let me just double check. Oh gosh, my memory is terrible. Good. And sorry, I'm rushing now because I am now late for a meeting. So 3x plus 1 for E. So your value of A is 3 and your value of B is 1. So your function g of x, now we've got, let me just get B. Sorry, I just need to scroll back up here. All right, so it's 1 over a x minus b. Okay. All right, so similar to what we did here, okay, but because we now have this translation, this horizontal translation, we've got to incorporate that as well. So 1 over 3 times f x minus 1, because your value of b is 1 over 3. All right, girls. All right, made it with a few minutes late, but all good. So a bit complicated, that one, but just a small part of the course. So as long as it's in your notes, that's good. All right, bye.